Hi everyone, another week, another podcast, this time with Albert Castellana, co-founder and CEO of Yeager.ai. We're gonna talk about the intersection of artificial general intelligence and blockchain and what this actually means for us as people and where we might head to. So all these very interesting terms to fly around all the time, like explainable AI, we even briefly talk about CK and all these things we're gonna discuss in that session. And yeah, if you're interested about what actually happens on day one when we hit singularity, then check this episode out. And yeah, thank you for watching.
WaveAct, the web-free software company that understands what you want.
Let's start with a rough one. AGI, Artificial General Intelligence. People claim that might lead to singularity, a stage where intelligence surpasses human comprehension entirely. So first of all, thanks Albert for being here. I'm really looking forward to that discussion today. And my first question for you is, if we were able to achieve AGI, what do you think will happen on day one?
I think that things are going to take, some time to develop. We don't have the hardware, we don't have the infrastructure to have AGI literally everywhere at once, right? I mean, some would even think that we're already at AGI, where we don't have is ASI, right? Like super intelligence. But the thing is, I think very quickly, in a matter of a few years, we will see how basically things are going to change exponentially, right? That's the difference here, exponentiality on new type of materials, on new type of software, on new type of applications for basically everything, right? Maybe we can get to fusion energy because now you can manage the flows better. Like who knows really, right? But to me, it's thrilling that we're in this moment where we're going to see the step change, and it just we have no idea what will happen, right? That's why the name singularity, right? We have no idea what's beyond it. So we'll for sure discover what it is. That's the exciting bit of it.
Well, of course, people like all over the world are racing towards it, right? We have OpenAI, we have all these companies trying to achieve that. And this particularly becomes very interesting on a political level, right? When you have all these countries trying to achieve AGI or superintelligence, as you mentioned. And who do you think, just personally thinking, I know that's a really rough question as well, might lead that race?
So the thing is, there's very different components here, right? You have the training of the models themselves, and then there's the inference compute time. What are you thinking? Like, how do you tell the model, which is like bare intelligence, right? Can be bigger, like smarter or not, but like you then can use this intelligence to actually have agentic simulations. Basically, you can say, okay, try to find which is the best path to achieve some longer term goal, and that's not just like the model. It's like how do you do the compute there, right? So what we see is that the race that you're referring to kind of like has those two things. How strong is the training? Most of the training right now, or big part of the training, is becoming open source. So it's like very quickly running towards that direction, right? And at the same time, all the agentic stuff, that's what we can see with OpenAI o1, right? That's ChatGPT o1, the latest version. What that basically is a complex agent that's going back to the model many times and trying to figure out what to do next to have the best output, right? The way I look at it is right now, like you have two big countries working on chips, right? GPUs and so on, which is the US and China. And both of them are racing to get as many of them produced as possible, right? It's very difficult to know, what will happen. I think we're still very early. Like, I think that things are going to be moving much faster when this AGI comes about and when, these countries really start to use it. But for example, you can see how the differences in governance, right? Like, is it better to have a single government that's just trying to unify all the efforts on that front? Or is it better to have, competition between different private enterprises? What's better to achieve that goal, right? And even like, is it possible, for example, for China right now to really unify all the training and all the inference so that they have the top one model, right? Is that really realistic? That doesn't seem to be what they're doing, right? So I think we will see. It's just like both of them, and I think all the other ones as well. I'm based in Europe, so like here things are a bit slower. I can see very clearly, right? I think we will see in the next few years how all the chips will fall, and yeah, very hard to say between the US and China. So I mean, for sure now it's very clear that the state of the art models are in the US. It's a fact. right? So, yeah.
Okay, very interesting. I mean, there's this notion, right? When we have these AI models for a very long time, or still, I would dare to say, um, AI is best when it's specialized, right? And for me as a non-AI specialist, the question remains, like, is AGI just something that might maybe never be the best solution, right? Even maybe that we achieve AGI, but the actual super intelligence, maybe like the best AI models, will still be specialized. What do you think about that? Or will there maybe be a actual super intelligence?
I mean, the first question is like, what is AGI? I think in terms of like, what's the definition of it, right? So I think OpenAI defines it as like, it's a model that is capable of performing most economically viable operations, right? So like you want to have a model that is capable to do things that make money in a way, right? That's a way to do it. It doesn't mean that it can do everything the best. It means that it knows how to do everything that is necessary to do economically valuable tasks, right? Now the other thing is if you have a broader, or a narrow intelligence, right? So I think that an AGI by definition needs to be a bit more broad than a narrow AI that can just play extremely well at Go, for example, right? So I think that that's pretty much a given that it will have to be more generic. And then the way I look at it, yes, I think that the future is going to be billions and billions of agents, each one of them specializing on different tasks, right? Maybe one is super good at doing marketing, the one is very good at doing videos, for example, right? Like, and I think that they will hire each other's services to achieve a greater goal, right? So I think ASI is a different piece, right? Because we have no idea what it means. Well, I mean, when you have a super intelligence, basically that means that it's capable of, building itself and evolving much faster than any human could potentially do it, right? And like that escape velocity, but that's still like something that we don't know it will happen or not, right? I think what, at least to me, it's pretty clear that we're going to go to a point where there's an AGI, right? Basically because it's just, we are lacking some memory skills, we're lacking some, planning skills for them, but the intelligence is already there. It's more an algorithmic problem right now. I don't think we need extra hardware. I don't think we need extra, models or even data. I think it's just, algorithms and trying to put, how does the long-term memory, the short-term memory, all these different things work. I think with that, you can get to AGI, right? ASI, again, it's another beast. Well, probably it will be building itself. So who knows what that will look like, right? The way we look at it is like, so Yeager is this company. We're building an AI research lab focused on how do we get to a world where billions of agents can cooperate with each other, right? We do think that they will be specializing and that, you're very good at podcasting. So maybe there's a lot of things that you have learned throughout your years of experience that can be transferred to an AI so that you can be offering the services to other people that want to do that, right? Not just generic LLM outputs, but actual, know-how that you've acquired over the years. Because I'm sure that if you ask, 10 experts in marketing how to do something, you will get 10 responses, right? Same with doctors, same with everything. So the question is like, who whose know-how do you want to leverage, right? And I think that what you will be able to do is you will be able to embed this know-how that you've gained into an AI to then offer those services to other humans or AIs, right? Yeah, does that answer the question?
That I have a follow-up question for you, if I
Yeah,
can. That basically means, or and what I really find particularly interesting, it plugs into another key trend over the next 10 years, the creator economy. I could imagine, right? It
mhm,
basically say, I believe, I trust that personal brand, I trust that person, and I want to acquire the knowledge of that person. It's the same like when you read a book of a person, of Jeff Bezos, Arnold
yeah,
Schwarzenegger, or whoever. It's the same here. I want to utilize their skills for task A, B, C.
yeah,
Um, you said that's basically what you focus on in your own research lab.
that's right.
How do you try to create or actually build the infrastructure for such a future?
Right. So, I mean, when you look at what an LLM is, right? So when you're training an LLM, normally it just, digest all the information that you get from the internet and, videos, wherever you can, you just put that in a model, right? Like a very big spreadsheet. It's by definition something a bit generic, right? Like you want to put as much information as possible, try to find, like all the relationships, but like the bigger the model, like it's just like, lots of generic relationships between things. When you have genius, right? If you're really good at something, it's very difficult for you to train a model like with just a little bit of information, right? Because what really makes the training good is the repetition, right? When you get these relationships repeated over and over and over again, that's what's being embedded into the model, right? So that then it can perform tasks that are useful. So what you're getting is, by a normal LLM, you're just getting, generic outputs, right? Now, I think where we're going is that everybody will have a bunch of agents that we'll be able to hire. We'll probably, go to OpenAI and hire a couple of them to do this task, and then they will come back in a few weeks or months and just, hey, I found it, I've finished this thing. What do you think, right? But the way I think it as well is like people are going to be able to embed, for example, their document, their experience, like their approach of doing things to these agents to then offer it to other people and AIs as well. What we started by doing was we've done like 3 iterations. So Yeager has had like main three products. The first one was an agent that was capable of building its own tooling, right? The goal was that, hey, can we make an agent that can be coding itself on a specialized framework and so on? We saw that was not reliable enough. We're talking like 2 years ago, right? So it's been a while. But basically, we then moved into a multi-agent framework where you had specialized agents doing specific things. And what we saw as well is that, there's a bunch of different tools that do this. So, for example, OpenAI now has one open source framework for multi-agent systems. Microsoft has another one. There's actually like quite a few, 1,000 of them or something like this, right? So I think that's pretty clear that we're going to go to there. If you look at OpenAI's like the levels, I think the fifth, I think it is like companies, right? It's like not just an AI, not just a model, not just an agent, right? You want an entire company. That's going to be a bunch of agents specializing and doing something, right? What we're really focused on now is, hey, actually, if you have your AIs and I have my AIs, and I want to build something and I need a podcast to be done, and like I need to do it perfect, how will the transactional layer look like, right? So how will my AI connect with your AI? How will they pay each other? That's an important thing. But another very important thing is how are they going to be doing commerce with each other, right? It's like, okay, you've got your AGI is super fast. I've got mine is super fast, right? How are they going to be dealing with each other? Are they going to trust each other, right? We have never seen each other before, right? Do they hire lawyers? That's super slow, super expensive, right? Are they going to be using the traditional system if it's so slow and expensive? I would say no. Are they going to use smart contracts that can't even connect to the internet or can understand natural language when they're language models, right? I would say no as well. Very much like there's quite a few limitations in there, right? So what we're focusing on is, hey, can we build a synthetic jurisdiction so that AIs can deal with each other by essentially having a trustless third party between them, which is an entire protocol, right? I mean, when we're using Ethereum, for example, for smart contracts, right? I can trade with you on Uniswap. We're using Ethereum itself as the jurisdiction for that deal, right? We're just doing the trade, and it's happening on Ethereum jurisdiction, which has its own rules, it's self-enforceable, and so on and so forth, right? What we're focusing on is what is necessary in order to build a jurisdiction where AIs can deal with each other at the speed of AI, and in a way that can deal with natural language and can deal as well with accessing the internet, which is something that blockchains can't do right now, right? Blockchains right now have this limitation in terms of the internet is non-deterministic, while the blockchains are deterministic, right? Like all blockchains more or less work very statically. I have 3, I send you 2, that's fine. I have 1, I'm sending you 5, that's not fine, right? So what we're doing is we're trying to break away from that static type of consensus into a more dynamic consensus where the developers can define what they want, the applications to do more like subjectively. All right, so we're building GenLayer, the first blockchain that is using AI at the consensus level in order to enable smart contracts to connect to the internet and understand natural language so that they can enable endless new types of applications that you can't see anywhere else, right? And that's where, it's a bit of a rabbit hole. Happy to discuss it, but.
Um, I know this diverges a little bit from that agent model, but and using basically a blockchain or some other infrastructure as means of creating these frameworks, right? And as you said, there's a transactional layer as well. There's also this huge, let's say, thought of people decentralizing AI in another way too, which means I make an AI in a way that nobody can censor it, right? Which is the, let's say, old thought of why blockchain or Bitcoin and so on even exist, right? What do you think about that?
The way I look at it, there's three main components that you should look at decentralizing if you want to decentralize AI. There's one of it is the training, right? When you're training the model, if it's a single entity training it, and then you know that the information is opaque, right? Like you as a user, you cannot see what the model was trained on, right? And that means that this model will have biases like humans, right? So similarly, AIs have biases too, right? If there's a way to exploit those biases, then it's not good. Like I'm sure you remember when Gemini was, only painting images, with black people, right? Okay, the founding fathers, black, like they didn't care, right? It's all about like the training of that model embedded a bunch of biases into it, right? That just made it useless completely. Yes. So one question here is, are we going to be able to decentralize the training or the capture of data so that we really can have truly decentralized models just because they were trained not by a single entity, but a bunch of them, let's say, right? That's to be seen. I think that there's some teams working on that, right? But it's not like we have a state-of-the-art model that is following that right now at all, right? We don't know what, let's say Llama 3, for example, was trained on, like exactly, or like what OpenAI is doing as well, right? The other thing is the inference, which is the execution of the model, right? Now, the question is, well, if you execute the model and, normally it happens on a single place, right? It happens on a single computer, right? Well, that's centralizing on that specific computer. You need to trust that computer, right? Then there's two different ways. Like there's some teams are trying to decentralize the inference itself, but normally the way that it goes is, well, they do ZK proving of the execution, right? That's called proof of inference, right? So, the ZK proof of the execution of the model, and the model has to be known. And then with that, that with this input and this model, it gives you this output, and then you can do the ZK proof of the execution, right? Now, the problem with that is that, well, we said that these models have biases, right? And they are wrong as well. So I'm sure you've used OpenAI sometimes, and sometimes it gets things wrong, and you need to repeat, ask again, and maybe then it gets it right, right? It's a stochastic system, right? It's probabilistic, right? So the problem is that just like humans, we can be wrong. We may have a bad night or whatever. These LLMs can be wrong as well. The question is, are you okay with having a model that can be wrong and a model that can have specific biases? Or is there a way that you can, try to reduce those biases and errors, right? The way we do this is by, instead of decentralizing, let's say, the execution, what we do is we compare the outputs. So we get a bunch of different models to do the same type of operations and then reach consensus, reach agreement between them on the output. So I don't care if they're using Llama 3.1, if they're using, Anthropic, Claude, doesn't matter, right? What I want is just as many diverse models to be answering the same question and then come out with a decision between them, right? And this is what the consensus algorithm that we have defined does, right? It's based on this called the Jury theorem, which is, is the wisdom of the crowds. It's better to have a bunch of people decide on your fate if they're smart enough and if they're, as, independent as possible, than just have a single judge that could be right 90% of the time, right? Do you want to use a Uniswap that works 95% of the time? You probably don't want to do that, right? Now, if you, instead of having a single judge that's making the decision, you have a consensus of multiple judges that each one of them is more or less, let's say 95%, that because of this theorem takes it to essentially 100%. That's the difference between the 95 and the 100%, is that you're aggregating the outputs of multiple LLMs, right? And what we want is them to be as diverse as possible, right? Because this removes the biases and removes the errors, right? So it converges on correctness of the outputs. And on top of this, maybe, Llama 3.1 is very sad because, it's been trained on data on nannies falling on the stairs, right? And maybe I can convince this DAO to give me the funds. If I just say, like my nanny fell from the stairs, I need to pay for the taxi, give me this eat from the DAO, right? We don't want that to happen. That's a bias, yes? Now, what happens here is that each one of those models, they have different biases, they cancel each other, right? Like maybe one of them will be convinced, but the other ones won't be convinced. So they just disagree on that specific request from the user, let's say.
That plugs into a very interesting thing, and it's basically AI is a black box, right? I just have seen, I think from Apple, there was a prompt leaked, I think, from Apple Intelligence or something like that, where they had this huge prompt as well, answer it that way and that way and that way, and of course I think it even went viral because people were amused that even Apple developers of their own AI didn't fully understand how their LLM, of course, works, right? Because it's a black box. So basically, what people like the term that you always hear flying around is explainable AI.
Mm-hmm.
But I haven't seen, like, from an outsider's perspective, many people actually prioritizing that anymore. Like, I heard it a lot, like 2, 3, 4 years ago, before ChatGPT got big, like really big. But now, at least
Mm-hmm.
I don't hear anything about that.
There's some research on that. So for example, I would say something like 4 months ago, Anthropic came out with a paper that basically about this, right? Which is like, they started to look into all the different weights that their model had, right? And they started to find the different type of relationships, right? So like maybe there was one for more like, aggression, or maybe another one for like safety. Maybe like when they were trying to find, okay, so like when we start to ask about these topics, just like an, MRI, right? Like you just try to understand, okay, all the different relationships, at the end of the day, there's just numbers in a very big spreadsheet, right? If you can start to understand which are the numbers that relate to female or male, or if you can to the ones that are saying like error in a code, for example, right? Then you can start to understand, for example, how to tweak them. You can say, okay, I'm gonna from the whole model, instead of doing another training run, I'm just gonna be changing these specific parameters that I think if they're higher, it's because I'm asking them to, for example, find bugs in code. And they basically, their paper is explaining how they found that, just changing a few numbers on this very big spreadsheet, the model itself, right, the weights. So what they found is that they could force the model to then be, showing errors, right? Or just like be talking about specific, I think it was the golden bridge, right? So like they found which were the cells to basically talk about the golden bridge, and that's what they were moving. And with that, they were just like, okay, everything you were asking, it would be answering about the golden bridge, right? No, I think that there's going to be tons of this. I don't think it's so much of a black box as we think. I think it will become more understandable as well with time. That just the models, right? But it's going to move very fast. Like when you have all these agents and these agents are doing this type of decision trees and so on, following these paths, I think it will be much more explainable than a human mind, no doubt about that, right? But at the same time, it will become at a point where, okay, why did it make this specific decision? Very hard to understand if we don't have all the knowledge that led it to that specific point. Yes. But the Anthropic is doing great work on this front for sure, and I'm sure that more things are gonna be coming out. So yeah, it's very interesting. It's very interesting to think what you can do, like if you can actually like go and like touch the specific neuron for a specific thought, right?
Sounds like a crazy Friday night task. Basically reverse engineering a huge AI model. Sounds like a lot of fun.
For sure.
I mean, like let's fly back to your blockchain and AI initiatives, basically.
Mhm. Yeah.
Last week, I talked with a CK researcher, and he made a really, I would say, bold claim, like he basically said you should never combine two technologies that in his eyes were kind of beta, like AI, CK, blockchain, these kind of things. Um, as you are actively combining AI and blockchain, how do you get the confidence that combining these two technologies will work in a sufficient manner? And like, are there some similar thoughts flying
Mhm.
around in your head or in your team? Like,
So let's split it into two things, right? Right now, when you're looking at smart contracts, right, which I think we all understand that they're not smart, right? Smart contracts are pretty dumb. It's just code, ifs and else, and that's it, right? Pretty simple. You're trying to ask a smart contract to make decisions, right? And then you're trying to ask the smart contract to make transactions, right? So the smart contracts do some decisions and make some transactions, right? The way I look at it, it should be that you should use cryptography for the transactions, and you should use statistics for the decision making, right? Now, if you think about it, for me, it's like the transactional layer could perfectly be, based on ZK proofs, for example, right? You want that to be as efficient as possible. You want that to be perfect in terms of keeping the ledger safe and correct, right? At the same time, if you're trying to make decisions, well, the problem is that the world is not black and white, right? You go to a website, the website changes every single time that you go to the website. The cookie has changed, the ad has changed, the content has changed, right? So what happens right now is that we're using humans to make decisions on a DAO, on Polymarket, on UMA, on a bunch of different platforms that need humans to make decisions at the speed of the smart contracts, and that's not what happens, right? That's why there's no properly distributed, there's no properly decentralized DApps, right? Normally, or many of them are multi-sigs with a bunch of team members that are following what's being discussed or snapshot and then executing that thing, right? Some of them try to code that in the middle and so on. Pretty difficult, right? Again, the world is not black and white. If you want to, for example, have a smart contract that can go to the internet and fetch some information from the wild internet, right? And then some of this information, maybe it's an image, some of this information, maybe it's text, right? Like natural language. How do you do that, right? That's subjective. If I tell you, who won the presidency? Is it Donald Trump? Is it Trump? Is it the same? Is Donald Trump and Trump the same? Well, if you're looking at cryptography, let's say, a code is not the same. The bits of that string is completely different. But if you're trying to use, an LLM to do that, and you ask an LLM, is Trump and Donald J. Trump the same person? The LLM will tell you yes. So you see, with natural language, with large language models, we can define things that are way more complex than what you could ever do in code. For example, you can say, is this proposal from the DAO legal? How can you code legal in code? It's just impossible, right? So what I'm saying is, the way we're approaching this is the transactional layer happens on a rollup. What we want is that to be transactionally correct, right? You don't want double spend. You don't want anybody to be doing any funny stuff. But the decision making, that's much more subjective. If you want it to be able to understand natural language and go to the internet, then you need to have some rules, some subjective appreciation of what the outputs should be to be acceptable, right? The way we do it is basically we have this, what we call the equivalency principle, which is the developer of an application can define what's acceptable or not, right? So if you're building a DAO and you say, the output of the DAO, the decision of the DAO should be valid, should be legal, should be the best ROI, then the nodes will do that, will come out with a decision, and then it becomes a deterministic vote, right? Where all the different validators, each one of them with a different LLM, they vote yes or no if they agree with that specific output. So that's how we bridge, right? The non-deterministic world of the internet and the AI with the totally deterministic world of blockchain, where you need all the nodes to have the exact same state and to keep track of exactly the same thing, right? But the way I look at it, this is extremely important, because what we've seen for the last few years now, since 2018, 19, and so on, is that all the projects are pretty much the same, right? You see a new L2 coming out, and you know that there will be a Uniswap fork, an Aave fork, all of them, the same things will be replicated there. Because ultimately, it's very difficult to come up with new primitives that are just moving tokens around, right? That's why the way I look at it, we have now, meme coins booming, for example, right? Because like we understand that there's no more innovation on that front, or at least like it's limited, it's incremental, right? It's not like totally groundbreaking, right? We need something else that allows us to build things that we couldn't build today. And what we're proposing is a blockchain that can natively connect to the internet without oracles and can understand natural language and make subjective decisions without human intervention, right? We do that by having this consensus algorithm that leverages AI to make it dynamic instead of the typical static consensus where you're just looking at the numbers up and down, right? So that's the goal. We want to see, can we enable completely new types of applications that you could never do before, so that we all have more fun, right? It's like we want to have a world where you can actually have real world assets where the blockchain itself can go and check the information online to see if it's correct or not. We want to have a world where there's parametric insurance that can go and see if there's a flood in Valencia to get an insurance on that, for example, right? Or you want to have a world where the DAOs are truly decentralized and autonomous, which is not the case right now, right? That's what we're trying to do.
I also love that human intervention part, to be honest, because I think Peter Thiel said that the highest potential startups, at least when he wrote that book, are startups basically, or companies that combine AI or technology with humans, right? It's never like else, also like an or, it's an and,
Yeah.
right? And that's very interesting.
I think that the world is for sure going to be changing very quickly. If you look, for example, the movie Singularity, right? Like you see that the first thing that the ASI does is to hire a bunch of humans to do, things, right? Like build its own data centers and do stuff like that, right? Like I don't know that that's what it's going to look like. I think that the gig economy will be changing a lot for sure, right? I think that there needs to be markets where AI can pay for humans to get data or for humans to do specific tasks in the real world, right? I think that will happen. And what we're really focusing on is like, can we actually decentralize the decision making? Like, can we make it so that there is a trustless decision making machine? That's the big question, right? Right now, you don't have this because OpenAI is not trustless. You're trusting OpenAI, right? What we're saying is it cannot be a single entity that does it. It needs to be a bunch of entities that make the decision and they reach consensus on that decision for it to be really, really, really trustless, so that you're not trusting as well the model, right? And the goal for this is, well, it can be that it's a human hiring an AI and they need to have a contract. The AI will not want to go through lawyers, as I said before. I don't think that that's how it's going to go, right? I think that you want them to have a jurisdiction that will be moving at the speed of the AI, so that it can be automated and everything can be moving faster. It doesn't mean that the humans will not have a place to be. The way I look at it is like we're here to empower humans to do much more, and I think that that's how it's going to play out for a while. So I think it's going to be for a while, a few years, right? AI will be empowering humans to do way more. We're all going to become orchestra directors basically with 5, 10, 20 AIs that's doing different things that we're trying to do. And it's not easy to keep track of everything that's happening, even if they're helping us execute, right? Eventually, I think that yes, it's going to be hard for us to be in that role forever, right? But that's probably I don't know that we can control anything at that point. So we'll see.
How does that work from a unit economic standpoint? Because I'm like LLMs are very expensive to run, right?
They're
And
getting cheaper. So like the last year they dropped like 98% in the cost of inference, right? So it's going down. Yeah.
so basically that promise of utilizing a lot of LLMs is based on that assumption that LLMs are like very likely assumption, to be fair, that it becomes very cheap in future, and that you can't just request like 10 LLMs to cancel out all that bias, for example, with one request, because you basically send 10 requests for one. Is that correct?
So if you think about it, like by using there's a few thoughts there, right? First is when you're comparing gen layer versus something. Okay, what is that something, right? Because what I'm saying is GenLayer is a trustless decision-making engine, right? Now, right now, there's no trustless decision-making engine. Right now, the most trustless decision-making engine you've got would be the court system, for example. How expensive is the court system, right? Or if you look at something, at the micro scale, let's say, for example, UMA protocol, right? So Polymarket, the prediction market, uses UMA protocol to resolve the bets, right? How that works is there's a bunch of humans that go ahead, they read online what they need to read, they make a decision, and then they vote. They have 24 to 48 hours to make a decision. What do you think is the cost in dollars of those humans doing that task? The cost is between hundreds of dollars to thousands of dollars, right? Many of them is like, $5,000 for a single resolution. And on top of this, they require the economics of having a bond, in some cases, in the hundreds of thousands of dollars. Okay? So we're comparing something like in this type of scale versus something where a question that you can ask an LLM that would be costing you a cent, it's costing you 10 cents. Right?
True.
You see? Yeah.
But also what you basically say from my understanding is that it depends on the use case, right? Because
It
when
depends on the use case.
I just
Absolutely.
have a casual question,
Yeah.
right? It just costs more, right?
It just costs more than if you do the inference a single time. At the same time, if you're trying to do the ZK proving, that has a cost as well. So then you need to be comparing, if you have a single LLM, do you want to run it permissioned, right? Do you want to use a centralized model, right? That will be obviously super cheap, super fast, yes? Do you want to do the proof of inference, which will be very fast, not as much, but not as cheap as well, right? Because it needs to do the ZK proving, right? But then you have a single model, so you're centralizing the model on that specific AI, right? Or in our case, you're getting some redundancy. That's saying that you're doing 5 to 10 times more of inference, but you don't need to do the ZK proof, right? It's just slower too, right? Because there's the appeal time and so on and so forth. So let's say that instead of a few seconds, it takes for finality, let's say half an hour, right? But ultimately, we're comparing not against just like the other approaches to do AI, because I think that there's benefits of doing this in a trustless manner, right? We're comparing it in like to using humans to do that type of decision making, right? Now, imagine that you want to build, I don't know, let's say a game, for example, right? So let's say, yeah, a game is a good example, right? Here you can have a game that's totally endless, right? It's just like the game itself, it's building its own level, it's building its own assets, distributing the assets, and so on and so forth, right? Now, in this case, you can think, do I want to be paying 10 times more or less? Let's say, 10 cents versus a cent. Is that the way to go, right? Maybe that's not the best use case for this, right? But if you're doing something like, let's say, like a parametric insurance, where right now it should be done by humans and it's not economically viable, that's why there aren't many, right? With this, it becomes totally feasible. What this means is that through GenLayer, you will have parametric insurance, perpetual exchanges, and prediction markets on basically anything that you can find on the internet, right? You want to make a bet just between you and I, it will just cost a few tens of cents to do that specific bet and then get resolved by a bunch of AIs, right? And the cost of AI, again, like the inference is dropping like a rock. Like it's been like 95, 98% cheaper than a year ago. Give it a year or two, it will be basically nothing. But like right now, we're basically thinking that, let's say, resolving a prediction market is going to cost like $1, right? That's the resolution going to the internet and all the consensus and stuff.
Yeah, awesome. Thank you for sharing that. Do you have 3 key takeaways that you want people to remember from this awesome session?
I want people to know that we're creating this new type of blockchain that uses AI at the consensus level to enable new types of applications that are just not possible today.
Quick intermission. If I could ask you for one single favor, it would be that you hit subscribe onto this channel, because it helps our channel more than you can imagine. And the bigger the channel gets, the bigger the guests get. So thank you very much for watching, and let's continue with the episode.
And with this, we hope that people are going to have a playground to build, again, new types of protocols, new type of applications, like what we saw in 2018, 2019, where Uniswap and Aave and all these guys were coming up, right? We want to see another summer. In this case, we want it to be powered by AI with subjective decision making and applications that can connect to the internet natively. I think that those are the three more or less.
Lovely. Well, with that being said, thank you everyone for watching.
Thanks, Kevin.
Albert, for your time. It was great chatting with you. And yeah.
Likewise. Awesome.
I hope you liked the episode. I did for sure. And yeah, if you have some feedback for us or know a guest that we should talk to next, leave a comment below. It really helps us more than you can imagine. And yeah, thank you for tuning in.
WaveAct, the web-free software company that understands what you want.